Welcome to the Explainer. Today we're tackling a big one. What really makes React so fast? For a library so focused on performance, the answer might actually surprise you. It's probably not what you've heard. If you've been in the React world for even 5 minutes, you've heard about the virtual DOM. It gets talked about like it's this magic secret sauce that makes everything fast. But what if that whole story isn't really the whole story? What if it's kind of a myth? So we're going to start right there. We're going to dive into this common belief, this idea that React has some secret weapon that just makes it faster than anything else out of the box. I mean, this idea is absolutely everywhere. You'll see it in tutorials, blog posts, you name it. But to really understand if it holds water, we've got to pop the hood and get on the same page about how React's engine is actually put together. Okay, to get to the bottom of this, there are really 4 key parts we need to wrap our heads around. Think of them as the main players in React's performance story. Let's do a quick rundown. First up, the star of the show, right, the virtual DOM. The absolute best way to think about it is like a blueprint of your UI. It's just a plain old JavaScript object that lives in memory, which means it's super cheap and incredibly fast to create and mess with. Next is reconciliation. So whenever your app state changes, React makes a brand new blueprint. Reconciliation is basically the process of playing spot the difference between the old blueprint and the new one. Its entire job is to find the absolute minimum number of changes needed. Then there's fiber. Now this is a huge deal in modern React. It basically lets React chop up big rendering jobs into tiny little pieces. Why does that matter? It means it can hit pause on its work to handle something more urgent, like you typing, and then come right back to it. That's what keeps the UI from ever feeling laggy or frozen. And finally, we have batching. So if you set state 5 times in a row, React is smart enough not to re-render the screen 5 times. It just doesn't. It groups them all together, or batches them, and does one single efficient update. Okay, so we've got our lineup: the virtual DOM blueprint, the reconciliation diffing process, the pausable fiber engine, and smart patching. With all that in our heads, we can finally go back and confront that big myth. And this is where the story takes a fun little turn. Here it is, the big truth. The virtual DOM is not what makes React fast. In fact, the whole idea that it's faster than the real DOM completely misses the point. Its purpose was never about raw speed. It's about enabling React to be smarter. And this really gets to the heart of the trade-off. A really good developer writing plain old vanilla JavaScript can absolutely manipulate the DOM directly and make something that's faster than a React app, for sure. So React isn't trading for raw speed, it's trading for a better developer experience and apps that are way easier to manage. See, at the end of the day, the slowest part of any web app is touching the actual browser DOM. That's the expensive operation. So React's strategy isn't to outrun the DOM, it's to be smart and interact with it as little and as efficiently as possible. So how does it do that? All right, so if it's not the VDOM's raw speed, then where does that snappy, performant feeling in React actually come from? Let's look at the real performance wins. The first huge win is that batching we just talked about. By grouping all those state updates together, React massively cuts down on the number of times it has to have a conversation with the slow real DOM. This is a massive source of efficiency. And the result of just that one update is huge. It lets the browser avoid constantly having to recalculate the layout, that's a reflow, and then redraw the pixels, that's a repaint. Every time that happens, you risk visual jank. By doing it just once, React keeps everything feeling smooth. The second win is just how clever the reconciliation algorithm is. It doesn't brute force compare every single thing in the UI tree. No way. It uses smart assumptions or heuristics, like only comparing elements at the same level. This makes the whole process incredibly fast. And this finally explains why React is always yelling at you to add a key prop when you map over a list. That key is a direct instruction to the algorithm. You're telling React, hey, this is the exact same item. It just moved, which prevents it from wastefully destroying and recreating that element from scratch. Now, a quick word of caution. You'll see tools like Memo, Use Memo, and Use Callback for optimizing re-renders. And look, they're powerful. But think of them as escape hatches, not defaults. They have their own cost, and if you sprinkle them everywhere, you can actually make performance worse. Use them when you really need them. So all of this stuff, it all builds into a much bigger picture. See, in recent years, React's whole philosophy has really evolved. It's moved beyond just efficient rendering to something way more ambitious, giving us total control over the user experience. So the goal isn't just to be fast. The goal is to be predictable. React is all about giving us developers the control to decide what updates and, just as importantly, when it updates. And this is where that fiber architecture truly shines. Because it can pause and resume rendering, React can prioritize what's most important to the user right now. An urgent update, like you typing in a search box, can literally interrupt a less urgent one, like data loading in the background. And that makes the app feel incredibly responsive. So that leaves us with the real takeaway. React's performance isn't about some magic trick. It's about a deep architectural choice to trade raw, unmanaged speed for something far more valuable in the complex apps we build today: predictable, fine-grained control over the user experience. So I'll leave you with a question. Which one do you think truly matters more?